We're back again, and this time we're talking about factorizing quadratic equations by completing squares. Okay, to complete the square in a quadratic equation, this is how we do it. We get the b term and we divide it by 2, we square it, and then we add it to x squared plus bx. So we'll get something like this: x squared plus bx plus half of b squared, which gives us a perfect square, x plus b over 2 squared. Alright, how do we do this? Here's one example. X squared plus 6x plus 1. To factorize it by completing squares, we go x squared plus 6x, and 6 here is the b term. We half it, or we divide it by 2, and we square it. This will make a perfect square quadratic expression. Now when we add half of 6, we must again subtract half of 6 again. Take note, we are squaring, so we must also square here. And then we complete the equation or the expression by including this 1 there, which is part of the original expression. Okay, now these two, adding half of 6 squared and minusing half of 6 squared, these are just extra terms to make perfect squares. Now what we did, we added and then we subtract again. See, when we add and subtract, we are not changing the value of the whole expression, because adding something and subtracting it again gives us 0, so we still get our original expression. We just need this to complete our perfect squares. So now 6 over 2 is 3, and 3 squared is a 9, so this bit is a perfect square expression in its expanded form. And these two terms are extras. Minus 3 squared plus 1 is a minus 9 plus 1. Okay, since the first term and the last term are square numbers, and the last term, the base of the last term is half of b, that is this format there, so it's a perfect square. So what we do is we just get the base of the first and the last term, a and c, and we put them in brackets and then we square it. Or otherwise, we can do it the long way. So we have x squared plus 6x plus 3 squared is a 9. So we find two numbers that multiply to give 9 and they add to give 6. And these two numbers are 3 and 3, positive 3. So our factors are x plus 3 and x plus 3, which is the same as x plus 3 squared. And the shortcut is you just get the base of x squared, base of the x squared, and the base of the c, and put them in bracket and square them. Okay, so we have minus 9 plus 1, and minus 9 plus 1 gives negative 8. And now we have x plus 3 squared minus 8. Now you see the first term in bracket is a square and we have a minus, so this kind of makes part of what we call difference of perfect squares. So to make the last term, this 8 here, to make it square, we square it, but then we have to take the square root again. We have to perform opposite operations on 8 so that the value does not change. It still remains 8. Just like we did up there, we added half of 6 squared and but then we subtract the same thing again. So we do the same here. When we square it, we do the opposite of squaring, which is square root, so the value still remains the same. And when we do that, we now have difference of two squares, a square, and their difference. And to factorize difference of two squares, it's easy. We just take the conjugate pair from their base. So the first term is x plus 3, and the second term is square root of 8. So the first bracket is x plus 3 plus square root of 8, and the second bracket is x plus 3 minus square root of 8, and we call these conjugate pairs. That's a special case that you get when you factorize difference of perfect squares. So the factors will be conjugate pairs. Let's see the second one. Here we have x squared minus 8x minus 3. Now take note, you can only do this completion of squares when the first term is a square number like x squared. So to complete the square, we get the b, we half it. Our b is a negative 8, we half it and we square it. So this completes the square from x squared minus 8x plus half of negative, no, half of negative 8 squared. And of course, once we add it, we must also subtract the same thing so that we do not change the whole expression. And we complete with the c value, which is minus 3. And this simplifies to negative 4 squared, which make up this perfect square, which we can factorize using the shortcut, the base of x squared, x, and the base of the c term here, minus 4. So x minus 4, square it. And the rest of the expression, negative 4 squared is a negative 16 minus 3, which gives negative 19. Okay, now we have part of difference of perfect squares, and I said here difference of two squares because we have two terms. So to make this 19 a square number, of course we square it, but then we must take the square root so that the 19 remains 19. And to get the factors of difference of two squares or difference of perfect squares, we will get the conjugates of their bases. The first base is x minus 4, and the second one is square root of 19. So one factor has a plus and the other factor has a minus between those bases. X minus 4 from this base plus square root of 19 from that base, and the other bracket x minus 4 minus square root of 19. And again, this is called a conjugate pair where you have the same terms, but one bracket has plus and one bracket has minus. And that is how you factorize a quadratic expression by completing the squares.